Welcome. In the previous video we implemented the compilation of integers and multi-argument function calls, and in this one we're going to start implementing the return statement. We are going to begin by adding a new token called token return, and then inside the tokenizer we need to shop the word return before we shop any ID. After that we can define a new AST node called AST return, and the value of a AST return is going to just be a list of ASTs called return expressions. We can now add all of the constructors, the first one AST value make return, and the second one AST new return. The implementation of the make constructor is quite straightforward, and the implementation of the new constructor is also quite simple. Now above the parser parse statement function, we can create a new one called parser parse return, and we can begin by asserting that the first token of the tokens list is a token return. After that we can advance the token and discard it since we are not going to use it. And then we can collect all of the return expressions. In this case, since the return statement is surrounded by parentheses, we can use the usual AST collect tuple while function. After that, we can simply just call AST new return, passing the expressions we just collected. Finally, inside the parser parse statement function, we can add a new condition to check if the current prefix is a token return, and if it is, we call the parser parse return function. Now inside the dump AST function, in our main.c file, we can add a new condition for the case AST return. We are just going to write return the number of expressions and then dump all of the expressions. We can make our lives a little bit easier by wrapping these conditions inside a static if instead of commenting out this code all the time. So we can begin by adding a if 0 here, then an else here, and finally a end if here. This means that we can swap between the dump of AST or compilation of the program by just swapping this 0 for an 1. Now if we run our script, you can see that we are parsing, in this case for this demo file, a return statement with two integers inside. Of course we are having an error since we haven't updated the writer yet. And inside our writer.h file we can update the writer write statement function to include the case of AST return. I'm also going to create this helper function called writer write indentation that is just going to write some indentation in the form of tabs. And I'm going to remove this for loop before the switch statement and instead call writer write indentation inside each case. This means that inside the case AST return we can begin by writing some indentation. Then we can compile the return statement itself. We can begin by the return keyword, an open parenthesis, the return type of the function, a closing parenthesis, and an open curly brace. We also need to extract the function definition name here. To do that, we can begin by asserting that the AST we are receiving is actually a function definition, and then we can extract the function definition name. We can swap also the name AST to function definition here. And since the previous AST was a statement, we can add a new parameter called statement. We must not forget to swap these names by statement, and right here in the write function call, we also need to swap this by statement. Now inside the case AST return, we can come back and add this for loop that is going to loop through all of the return expressions inside the statement. And for each return expression, we are going to write some indentation, followed by the name of the field of the return type structure for this function. Then we write the expression itself. And finally, we finish by writing a comma followed by a new line. After writing all of the fields, we need to once again write some indentation and close our struct constructor with a curly brace. We must also not forget to break the case condition at the end. Since we modified the writer write statement signature, we now need to update the place where it is called. Here we need to pass the AST function definition. In this case it's simply called AST. Now we can come back to our main.c file and swap this 1 for a 0. So we are now compiling the program. And now if we run our run script for this specific demo, you can see that we are getting some errors related to C code, but if we see the generated code, you can see that it is actually what we expected. So we are returning a new object of type secrets return type, and all of the fields are being properly assigned. If we include a dummy main function so that the C compiler does not complain, and run the script again, you can see that there are no more errors and the generated code is quite similar. It just calls secrets inside main. Of course this works with any amount of return types. For example, if we add a third one of type float and the expression is a value 3 and we compile the program once again, now you can see that the generated code has a third field with name underscore underscore to underscore underscore, type float, and it is being properly assigned here when we return from the function secrets. And this is how we compile return statements in C. In the next video, we are going to start parsing variable assignments.